Hey everyone, and welcome to NoelsMarine. Today, we're going to go deep, right down into focus on the freshwater generator explained marine engineering. Have you ever actually wondered how a ship out in the literal middle of the ocean gets its fresh drinking water? Well, the answer is this absolutely brilliant piece of marine engineering called the freshwater generator. Sometimes you'll hear it called an evaporator or a desalination system. In this explainer, we're going to break down the entire working principle of the freshwater generator, keeping it simple but totally technically accurate.
Chapter 1. Why does a ship even need so much fresh water? Think about it. A ship at sea is basically a floating city. Every single person on board relies on fresh water just to survive. We're talking drinking, cooking, bathing, laundry, cleaning, the whole shebang. But it's not just for the crew's human needs. The ship itself actually requires highly purified fresh water for some absolutely crucial engineering operations, like boiler feed systems and engine cooling purposes. Now, carrying massive, super heavy tanks of fresh water for a voyage that lasts months, that just isn't practical, and it takes up way too much space. So ships literally have to produce their own fresh water directly from the ocean around them. And that's exactly where the freshwater generator, or FWG, becomes absolutely essential.
Okay, before we get into the heavy machinery, let's take a look at nature. How does the Earth make fresh water? Well, it all happens naturally through the water cycle. When sunlight heats the ocean, the water evaporates. The heavy salt gets left behind, right? Meanwhile, that pure water vapor rises up into the atmosphere, where it cools down, condenses into clouds, and eventually falls back to the surface as fresh rainwater. So nature is basically already teaching us the fundamentals of desalination. A freshwater generator just copies this brilliant natural process, but it speeds it way up and traps it inside a highly controlled machine.
So, if we just boil it down, pun totally intended, to a simple formula, nature's process is literally just this: evaporation plus condensation equals freshwater production. That is the core equation we're dealing with here, folks, and it's exactly what our machine is going to replicate on board the ship.
But here's where we hit a major engineering challenge. Normally, at atmospheric pressure, seawater boils at 100 degrees Celsius. On a ship, there's absolutely no way we want to waste precious, expensive fuel just heating seawater to those massive temperatures just to get a drink of water. So, engineers asked a really fascinating question. Can seawater boil at a lower temperature? And the answer is yes, if you change the environment by reducing the pressure. This one simple concept is the main scientific principle driving the entire freshwater generator system.
And that brings us to the vacuum principle. You see, the freshwater generator operates entirely under a vacuum condition. Now, what does a vacuum actually mean in this context? It simply means we create an enclosed space with very, very low pressure. Basic physics tells us that when pressure drops, the boiling point of liquids drops right along with it. Check out this comparison. At normal atmospheric pressure, water boils at around 100 degrees Celsius, right? But under a strong vacuum, water might actually boil at just 45 to 60 degrees Celsius. That is a massive drop. It means seawater can evaporate using very low temperature heat, making the whole system incredibly energy efficient.
So, since we only need about 45 to 60 degrees to boil water under that vacuum, where do we get the heat? Well, ships don't usually burn extra fuel just for freshwater production. Instead, they do something super clever. They recycle waste heat that the engine is already generating anyway. Usually, this heat energy is captured from the main engine jacket cooling water. This hot water already exists. It's constantly circulating in the engine's cooling system to stop the main engine from overheating. So instead of just dumping all that perfectly good heat into the ocean, it gets reused. The hot jacket water passes through the heater section of the freshwater generator. It literally converts waste heat into life-saving fresh water. Honestly, that's just smart marine engineering at its finest.
All right, let's walk through the main components that make this magic happen. First up, we have the ejector pump. Sometimes they call it the seawater pump. This guy has two main jobs. First, it supplies the necessary raw seawater into the system. But more importantly, it creates that all-important vacuum inside the chamber by aggressively pulling out air and unwanted gases. Remember, without that vacuum, the internal pressure won't drop, and our low-temperature evaporation just isn't going to happen.
Okay, so once that vacuum is firmly set, the seawater flows into the heater or evaporator section. This is where that hot jacket cooling water we just talked about is flowing safely inside a series of enclosed tubes. The incoming seawater surrounds these tubes. And because the pressure inside the chamber is incredibly low right now, the moment that seawater hits those warm tubes, it instantly starts to boil at a much lower temperature. It quickly changes into pure water vapor, leaving all that heavy salt and those impurities sitting behind at the bottom. This, as you probably guessed, is the evaporation stage.
But, an important problem appears here. As all that vapor vigorously rises up, the steam can accidentally carry tiny, unevaporated droplets of salt water right along with it. And obviously nobody wants salty water mixing into their fresh drinking supply. To solve this, the vapor is forced through a specialized component called a demister. Think of it like a physical trap. It catches and strips away any of those lingering salt particles or heavy moisture droplets from the steam, making absolutely sure that only the cleanest, purest distilled vapor makes it to the next stage.
With those salt droplets completely removed, the clean vapor flows right into the condenser section. In here, cold seawater straight from the ocean is getting pumped through a completely separate set of cooling tubes. When that hot, pure vapor hits those freezing cold tubes, boom, it rapidly cools down. The vapor undergoes condensation, changing from a gas back into a liquid state. And just like that, we now have fresh, distilled water literally dripping off the tubes.
Finally, before anyone can actually drink it or before it's sent to the delicate boilers, we have to check its quality. Enter the salinometer. This device acts like the system's incredibly strict gatekeeper. It constantly measures the salt content, or salinity, in the newly produced water. If that salt level reads even slightly too high, the system immediately rejects the water, preventing it from ever entering the freshwater tank. But if the quality is perfectly acceptable and pure, it gets routed straight into the storage tanks, safely protecting both the ship's internal systems and the crew's health.
All right, let's put it all together and see the whole sequence flow continuously as one operation. Step 1, raw seawater enters the system. Simultaneously, the ejector pump goes to work, rapidly ripping out air to create a strong vacuum inside the chamber, dropping the pressure. With the pressure way down, the hot jacket cooling water arriving from the main engine easily heats up that incoming seawater. And thanks to that vacuum, the seawater hits its boiling point at a super low temperature, rapidly evaporating into rising steam, leaving the dense salt securely behind.
Next up, that rising steam is forced right through the mesh of the demister, where any sneaky saltwater droplets are caught and drained away. After that, the perfectly pure steam enters the condenser section, hitting cold seawater tubes and cooling back down into liquid droplets. Finally, we collect that fresh distilled water and the salinometer runs its crucial purity check. Good water goes straight to the freshwater tank for the ship to use, poor quality water gets instantly rejected back into the ocean. It's this seamless, continuous cycle turning raw ocean water into a vital lifeline on board. Of course, no machine is perfect, right? Marine engineers have to stay constantly vigilant. If you get an air leak in the seals or the ejector pump acts up, your vacuum pressure drops, and that leads directly to poor evaporation. What if the demister is damaged or there's an internal leak in the condenser tubes? Well, you'll end up with high salinity, salty fresh water, and the salinometer will start rejecting it left and right. And inevitably, over time, salt deposits are going to cause scaling on the heater tubes. That scaling acts like an insulator and severely reduces your heating efficiency. And that is exactly why meticulous, regular maintenance is a massive part of a marine engineer's daily routine. So, let's summarize everything we've learned today. A freshwater generator works by copying nature's age-old water cycle, but it supercharges it for the maritime environment. By combining evaporation and condensation with powerful vacuum technology, it easily converts raw seawater into pure fresh water. Instead of wasting valuable engine heat, ships cleverly reuse it to boil water at incredibly low temperatures. It really is one of the smartest examples of engineering efficiency out there. If you found this breakdown useful, give the video a like, share it with your fellow engineers and maritime cadets, and subscribe to NoelsMarine for more detailed deep dives, freshwater generator explained, marine engineering. Hit the bell icon so you never miss an upload, and we'll see you in the next one.